Welcome to Automotive Insiders. I'm your host, Jason Stein. Great to have you back listening again with us. Today, we're looking at a powertrain mix that shifted meaningfully just this year. Battery electric vehicle market share sliding from roughly 10% late last year down to about 6% today. Hybrids picking up the slack, and a regulatory picture reshaped by the One Big Beautiful Bill Act, the fight over California's Clean Air Act waiver, and EPA's endangerment finding. My guest is Ian Smith, Automotive and Transportation Battery Product Manager at UL Solutions, where the team certifies and validates everything from EV chargers and battery packs to the fluids, wiring, and functional safety systems inside every kind of vehicle on the road. There's lots to talk about today, from electric to hybrid to internal combustion and the road forward. Ian is my guest on Automotive Insiders. Well, Ian, thanks so much for being on the program.
Yeah, thank you for having me. I'm excited.
Let's start with the regulatory backdrop because it's moved fast in 2026. The One Big Beautiful Bill Act, the fight over California's Clean Air Act waiver, EPA's endangerment finding, and shifting federal tax incentives were all part of the mix. How do you describe the current state of the U.S. powertrain mix right now, and how much of what we're seeing is policy driven versus real underlying demand?
Yeah, so that's a really great question. Over the past almost 2 years, really, there's been a ton of changes in the U.S. regulatory landscape. You mentioned the One Big Beautiful Bill, California's air waiver, EPA's endangerment finding. All of those directly impact the, incentivization for manufacturers to be really pushing electrification. And that's really starting to cause a little bit of a softening when it comes to the powertrain mix in the U.S. Towards the end of last year, we were seeing kind of market highs around 10% market share for battery electric vehicles. Now, over the past couple of quarters, that's kind of saturated to about 6% market share for battery electric vehicles. And we're starting to see a whole lot more hybrid electric vehicles starting to start an uptick in terms of market share. And so it's kind of leading into this bit of an uncertainty in terms of where is the future powertrain mix in the United States going to head.
I mean, you kind of described it extremely well. The EVs had a genuinely fast rise in the U.S. Now the growth is somewhat stalling out. Walk us through both sides of that, why it rose in the first place, what's actually behind the slowdown, and maybe bring us into UL's role in that world, your work in EVSE, charger certification, EV battery validation, and certification testing.
Yeah, certainly. So the big push came a number of years ago when there was updates to the fuel economy standards as well as the greenhouse gas emission standards that were really forcing manufacturers to look into ways to improve both fuel economy or reduce greenhouse gas emissions. Kind of in hand with that, there were a number of incentives, tax credits primarily, that were focused on making electric vehicles or plug-in hybrid electric vehicles more affordable. Those two kind of pushes on the regulatory side helped spur a early adoption mindset for a number of different customers wanting to be part of that wave or influx in electric vehicles. And then at that same time, there was quite a bit of federal funding that was looking towards building out the charging infrastructure in the United States. We're a pretty unique country in that we're so large and kind of spread out that charging infrastructure is extremely important. And so that's kind of the background as to why we saw that very quick rise in the United States. Now, in terms of the different types of services that UL Solution provides to help make sure that those products and components are safe, you had mentioned EVSE, so the vehicle charger. We do quite a bit of certification, evaluation, and interoperability testing on those. So on the certification side, looking to make sure that the products are safe, they don't, shock somebody inadvertently or have overheating hazards or things like that. From an interoperability perspective, making sure that charger from manufacturer A works with every different vehicle that you could possibly get here in the United States, and then more. And then when it comes to the battery side of things, UL's been working in the battery space for several decades, and we just recently opened up a lab in our Auburn Hills, Michigan area, focusing on battery validation testing. So that's going to be, electrical performance and life testing, mechanical vibration and shock, environmental testing, safety testing under catastrophic conditions, all to make sure that the products that manufacturers are bringing to market are safe, they perform as they are expected to, and really just meet all of the different requirements that OEMs have, as well as certification standards and regulatory requirements.
This isn't just a U.S. story, obviously. We've talked about that on this program many times. You're running a global lab network, and the EV path is still very much alive in the EU and obviously in China. How does that global footprint change the value you bring to a North American supplier trying to plan its own EV strategy?
No, that's a great question, a great comment that you bring up in terms of it's not slowing down everywhere, right? We're seeing the European Union still continuing on with their greenhouse gas reduction requirements for OEMs, maybe a little bit of a softening there, but China is certainly doubling down, requiring continued reductions in greenhouse gas emissions for their vehicles, and continued improvement for the efficiency and performance of those battery electric vehicles. Now, UL Solutions has a number of different battery labs globally. Of course, we have our North American battery lab located just outside of Detroit, but we also have labs in Changzhou, China, to support the Chinese manufacturer base there. We have labs in Pyeongtaek, South Korea, also to support the manufacturers that may be in South Korea. We have a lab that's in Aachen, Germany, to support German manufacturers, primarily from an early stage product development perspective, focusing on cell performance and cell safety. And then we have additional research and development labs that are located in Taiwan to help manufacturers that are wanting to evaluate new types of materials, new chemistries, things like that.
There's obviously a real pivot of late towards hybrids, plug-in hybrids, and a renewed focus as well on internal combustion. What's UL's role in that shift? And I would say particularly around automotive fluids and fuels testing. And for plug-in hybrids specifically, you still need both EVSE and battery testing. So how does that dual requirement change how a supplier plans its testing budget and perhaps its timeline?
Yeah, certainly. So on the battery side, regardless of if it's a plug-in hybrid vehicle, a conventional hybrid vehicle, or a battery electric vehicle, there's still some amount of validation testing and also regulatory or certification testing that needs to be done. Rather than just working with a 1,500-pound battery pack, now you might only be working with a couple 100-pound battery pack or something that's the size of a suitcase. And so the global lab network that we have is still more than capable of supporting those product architectures. Now, you had mentioned, with the shift maybe a little bit here in the United States back towards the conventional powertrains, internal combustion engines, things like that, our engineered materials group does have the capability of doing fluids type testing to evaluate things like material compatibility and more. So if you're starting to develop these new types of powertrain designs, and thermal management is key regardless of if it's a battery electric vehicle or an internal combustion engine vehicle. Looking at those fluids that provide the heat transfer and making sure that they're compatible with the different types of materials that are in that cooling system, so you don't have down the road some kind of catastrophic failure or safety incident.
Beyond powertrain specific work, UL supports the full vehicle. A few examples: EMC, product safety for components like wiring and connectors, functional safety under ISO 26262. It goes on and on and on. General mechanical, environmental testing of components. For a supplier trying to prioritize across a list that's very broad, where do you actually tell them to start?
So that's a really good question. I think it's going to be very much dependent upon the manufacturer and the exact product that they're making and where they're at in their development process. So typically in the development process, there's what we call a development V. So it starts from what are the early requirements, definitions, how do those cascade down into component or material level requirements? And then from there, going back up the V on the right side, there's going to be some kind of testing to verify that they're meeting what those requirements are. And so, again, it's going to really depend on if they're a supplier for, let's say, a headlight assembly, as an example. They're going to need to go through at some point some mechanical or environmental testing to make sure that those products meet the requirements that manufacturer has, as well as what their end customers may have. But there's also going to need to be some safety verification as well, right? Making sure that the connectors that are used don't have problems with isolation or short circuit. Making sure that those products meet the regulations for EMC or EMI. And then kind of on the other side of that spectrum, on the functional safety side and software side, with these vehicles, all vehicles really getting more and more connected to, wireless networks and over-the-air updates and communication between different subsystems or components, making sure that the cybersecurity and the functional safety performance of those products is paramount, right? So making sure that you have safety built in at every layer, whether it's a hardware layer or a safety layer.
Ian, this has been a great conversation, a great overview of where the world is from a powertrain perspective, and then some. Thanks so much for being on the program.
Of course. Thank you for having me.
Thanks again to my guest, Ian Smith, Automotive and Transportation Battery Product Manager at UL Solutions. And thank you for listening to another episode of Automotive Insiders. Come back to your favorite platform for our next podcast with an industry-leading executive. I'm your host, Jason Stein. Thanks for listening to the program. We'll see you again next time.